Welcome. Here we go. Chapter 9, Section 5. We deal with adding and subtracting and multiplying and dividing complex fractions. Now we're going to, complex fractions using functions. Now we're going to use complex fractions and see what these are and what this means. Of course, there's always a PDF if you want to go and find it out there and print it off. Hopefully I put the right one out there this time. I want to talk about complex fractions. Complex fractions. There's a couple ways of dealing with these. I'm going to talk about one, and then I'm going to talk about what we do and why we do it. The first way is the way we've always talked to you about doing this, is if you ever divide by a fraction, what you really want to do is multiply by the reciprocal. So you do 1/2 times the reciprocal of 3/5 is 5/3, and you get 5/6. Do not write down these notes right now. I will tell you when to start writing things down. I'm talking about old ways of doing this and the new way of doing this and why. So 1/2 divided by 3/5 is the same as 1/2 times 5/3, which gives me 5/6. We've multiplied by the reciprocal. But, well, there's other ways of doing it. If we do what we were doing, and we go ahead and get a common denominator, and I'll explain why in a little bit. If I multiply this by 5/5, and I multiply this by 2/2, I'm going to get 5/10 divided by 6/10. And when I do my multiplication, I get 5/10 times 10/6. The 10s cancel again. I get 5/6. So this is getting a common denominator first and then doing my normal multiplication. That's not very different from what we had been doing. This is a little bit different, but this is a lot more powerful, and it makes things easier. So this is what I want you to do. Like on finding a common denominator, I want to find my LCD. Well, for this one, my LCD is 2 times 5, or 10, just like I did. You can start copying down these notes down. My LCD is 10. Instead of finding a common denominator and using it as a common denominator, what I'm going to do instead is I'm going to multiply by 10/10. So what this becomes is 1/2 times 10/1 divided by 3/5 times 10/1. Multiplying by 10/10 is multiplying by 1. It doesn't change anything. But watch what happens. My 2 and my 10 cancel, giving me 5. My 5 and my 10 cancel, giving me 2. 3 times 2 is 6. I get the same answer of 5/6. But this method is going to make a couple things a little bit easier. So this is the method that I want to use. So let's go to example 2 and double check you get the methods. First thing I want to do is find my LCD, my least common denominator. In my first denominator, I have an x. In my second denominator, I have a 5. So my least common denominator needs to be 5x. So I'm going to multiply my numerator and my denominator by 5x. When I do this, the small fractions, the denominators of the small fractions should almost always cancel out. 1 times 5 is 5. The 5's cancel. 3x squared times x is 3x cubed. Every single time I do this, my small denominators should cancel out every single time, leaving one fraction, not two fractions within a fraction, but leaving one fraction. This makes example 3 easier, while the other steps would make it more difficult. Example 3. I have fractions, but I also have fractions within fractions. But this here, my numerator, I have a fraction and a whole number. And that's where this multiplying by my LCD in the numerator, the large numerator and the large denominator, makes this a little nicer. So example 3, LCD. For my numerator, I have an x squared. If I had a denominator here, I would need to make sure that I use that for my least common denominator as well. Here I have an x, and I have an x in that x squared, so I've got that taken care of. So now I'm going to multiply my numerator and my denominator of the large fraction by x squared. X squared. Now what I'm going to be doing here, since I have a binomial, is I need to distribute the x squared into both of my terms. So I'm going to get, that should be a fraction bar, because x squared divided by x squared is 1. Distribute the x squared times 1 is x squared. X squared by times 1 over x is minus 1. Divided by, use a different color, x squared times 1 is x squared. X squared times 1 over x is plus x. I just reduced this 1 minus 1 over x squared divided by 1 plus 1 over x to x squared minus 1 over x squared plus x. That's a nicer fraction, but I'm not done because my numerator here is factorable. This is x plus 1, a difference of squares, x minus 1. My denominator is I can factor out an x, and I get x plus 1. My x plus 1's cancel, so my final answer is x minus 1 over x. Remember, I cannot cancel out the x from the x minus 1 and the other x because this is a term and this is a factor, so I cannot cancel them out. This entire thing is my final answer. Whoa. Let's try this again. Let's try example 4. So I want to look at all my little denominators and find my LCD, my least common denominator of all my small denominators. Okay, so if I look at my top denominator, I have x plus 2, so I need an x plus 2 in my LCD. This also is just 1 out x plus 2, so I've got that covered. And this is just an x, so I need times x. My LCD is x plus 2 times x. I'm going to, again, multiply the numerator of the large fraction by my LCD and my denominator of my large fraction by my LCD. Now the nice thing about my numerator is there's no addition or subtraction in the two fractions. It's just one fraction. So the x plus 2's cancel, leaving 2x. Now my denominator is not going to be as nice. I need to distribute my LCD into both fractions. And I need to write it so I can actually see what the two fractions are. So 1 times x squared plus 2 times, x plus 2 times x is x plus 2x over x plus 2 plus, now multiply my x plus 2 times x times 2, so I have 2 times x plus 2 times x over x. Again, the purpose of multiplying by my LCD in the numerator and denominator is these should cancel. So I get 2x over x plus 2 times x plus 2. Distribute the 2 in, I get 2x over. Now, before I do that, some people are like, ooh, there's an x and there's an x. You cannot cancel that because this is a factor and this is a term. Do not cancel those out. Do not cancel those out. I have to simplify my denominator first, then I can do some canceling out. So I have x plus, distribute the 2. I get 2x plus 4. So I get 2x over x plus 2x is 3x plus 4. This cannot be reduced anymore. That is my final answer. I have one more example for you. It's of the same style, making sure that we understand how this does work. Let's look at example 5. Example 5. One more time, I need to find my LCD. Well, first of all, I need to factor out this top denominator. X squared minus 4 is x plus 2 times x minus 2 over, this is the same one, over x plus 2 over x. Let's find my LCD now. My LCD for the top denominator, I need an x plus 2 as a factor, an x minus 2 as a factor. For this denominator, I need an x plus 2. I have it. For this denominator, I need an x. So once again, I have to come through here, multiply my numerator by my LCD, and multiply my denominator by my LCD. If I do this correctly, I should only have one fraction and be able to simplify it. One more time. Since this is one fraction in my LCD, in my numerator, in my top, I can go ahead and just cancel out what I have in common, the x plus 2 and the x minus 2, which leaves me with 2x. In my denominator, I'm not so lucky. I have to distribute over into the binomial, over that plus sign. So if I do this, the first one, I get x plus 2 times x minus 2 times x over x plus 2 plus 2 times x plus 2 times x minus 2 times x over x. And again, I should expect these small denominators to cancel out. And if I continue, my numerator stays the same, 2x. My denominator is now x squared minus 2x plus, well, I have to FOIL this out. This is, well, we know that this is x squared minus 4 times 2 is 2x squared minus 8. Combine like terms, and I end up with 2x over 3x squared minus 2x minus 8. Now, is this factorable? It might be factorable, but honestly, at this point, I have nothing over here. I'm not going to be able to factor out an x unless there was a greatest common factor of an x, and there's not. So I would leave it like this. If I wanted to factor it, I would say what multiplied to be negative 24 and added to be negative 2. And I would probably come up with negative 6 and 4, and we would be able to simplify that. But really, this is as far as I can go with this example. So we're going to be right over 15 minutes. That are the 3 examples that I have, actually the 5 examples I have for you. I'll see you in class.